All right, section 9.3 is dealing with significance tests for a mean, a single mean. We'll be covering two tests, but really we're only going to be doing one, but I guess technically it's two. We're going to be doing a one sample Z test from mu and a one sample T test from mu. Similar to confidence intervals, if the true population standard deviation is known, we are going to run a Z procedure. And if sigma is unknown, which is going to be 99% of the time, we are going to run a T procedure. Remember, the T distribution accounts for that extra variability given to us whenever we use our sample standard deviation to estimate the population standard deviation. This value is not good for small sample sizes, so a T will compensate for that. Let's review the assumptions. Random check, 10% condition check. Hopefully we don't need to talk about these too much anymore. Got to have a random sample that assures us that our X bar is going to be an unbiased estimator for our mu. 10% condition, this allows us to use the formula for the standard deviation of the sampling distribution. And then large counts assures us that the sampling distribution of X bar is going to be approximately normal. Again, be careful with this one. We didn't do too well on our last test with this third check. The sample size is big, you're good. Bigger than 30, you're good. If it's smaller than 30, take a look at a graph of the sample data. If the sample data is approximately symmetric with no outliers, then we assume the population distribution is normal, and therefore the sampling distribution is normal. All right. Do not use T procedures if the graph shows strong skewness or outliers. But also let's remember that even if this check kind of fails, T procedures are pretty robust with respect to this check, so they're still pretty good. So we usually run the test anyway. If sigma is known, well, actually it doesn't matter if sigma is known or not. This is the null and alternate for both tests. It's mu is equal to some number against the alternate that it's less than, greater than, or not equal to. Our test statistic, if sigma is known, will look like this, where we have the true population standard deviation in there. That's what makes this thing exactly this test statistic normally distributed. If we have to put S in there instead, that test statistic no longer has a normal distribution. It has a T distribution with n minus 1 degrees of freedom, where n is the sample size. Okay, remember those normal curves look like this, and the T curves are just kind of got some extra area on these tails here to account for that variability in our estimate not being very good, right? One-tailed test, greater than, you find the area above the test statistic. Less than, you find the area below your test statistic. And again, with a two-tailed test, you see where your test statistic is. If it's down here, then you find the area below it and you double it. If it's up here, then you find the area above it and you double it. Okay? For T-step, make sure you report the test statistic, and also, you don't have to do it for the T-step, but you have to have the degrees of freedom somewhere on your paper. All right, so let's just get right into an example. I'm going to load this into the calculator real quick. All right, so here's the length of these sub sandwiches. Abby and Raquel like to eat sub sandwiches. However, they notice that the lengths of their 6-inch subs tend to be shorter or longer than what was advertised. So they're wondering if their 6-inch subs really are 6 inches. So to investigate, they randomly selected 24 different times, and they went in and they ordered a 6-inch sub. Here are the lengths of the 24 subs. So you can see a lot of them are smaller, right? A few are right on and a few are bigger. But it looks like on average, it looks like they're a little bit light, a little bit too small. Do these data provide convincing evidence at the 0.10 level that sandwiches at this restaurant are different than advertised? So they're not saying smaller or larger, they're saying different. That's going to give us our alternate. All right. What is the true population parameter? In this case, it is a mean. It is mu, which is the true mean, I like to say population. The true population mean length of all subs at this shop, and you want to be really technical, this month. You know, like I said, I don't know how. Just make sure you're saying something about the true mean length of all the subs at this shop. Hypotheses. So our null is going to be that the true mean is equal to 6 against the alternate that the true mean is not equal to 6. Different than. Read the stem of the question to figure out how to word that, which alternative to use. Assumptions and conditions. Number 1, they randomly selected the times. So we're good. 2, 10% condition. N equals 24 is likely less than 10% of all subs for the month. Or technically, I guess you'd say is actually less than 10% of all possible times they could go order the subs. Whatever, it's fine. Third check is called normal large sample. Unfortunately, our sample is not large enough. N equals 24 is less than 30, so that's not good. So let's take a look at our sample data to see if our sample gives us evidence that the true population distribution is perhaps normal, maybe, which is a ridiculous thing to, well, whatever. That's what we're doing though, right? We look at this sample and we say, does it look like this could have came from a population that was normal? We're really just looking to see if this, don't say this thing is approximately normal. You will lose points if you say that. Just say it's approximately symmetric with no outliers, so we're good. I'm going to copy down a box plot because they're easier to sketch. I don't see a little skewed, but not significant skewness, so I'm going to say we're good. So for 1 point, you have to copy down the graph. That is an absolute requirement on my test and on the AP test. So please do it. And you have to copy it down, not perfectly, but the reader needs to be able to know that you actually graph the data. So I like to put one value on here. I'm going to say 6 is right at Q3 there. Then you need to make a comment on it. The sample data has, I'm just going to say no outliers. Usually I comment on both. Usually I say is approximately symmetric with no outliers. But I can just say no outliers. That's good enough. Therefore, the sampling distribution of my sample, which is X bar, is approximately normal. Again, guys, I require this on my test. You have to give it to me or you lose a point. Whatever, right? Do it. Name the test. This is a one sample t-test for a mean. Why t-test? Because I don't have any population standard deviation anywhere, right? And this is a good place to put the degrees of freedom. With degrees of freedom equal to 23. I got a sample size of 24. 1 less than 24 is 23. So you don't have to put it here. It just needs to be someplace on your paper. So get it on there somewhere. Test statistic. I require the formula and the value. So a t, again, it's a z-score. Think of it as a z-score. What's your value? Well, my value is an X bar. What's the mean of the sampling distribution? Well, if the null is true, then the mean would be 6. Or I guess for symbols, I would put down mu naught. Over, now the standard deviation is sigma over square root of n for these, but I'm going to put in S. over square root of n, because I don't have sigma. Put in the values. I actually don't know what my mean is, so let's calculate that. So let's menu, statistics, stat calculations, one variable statistics, length. So my mean is 5.677. 5.677 minus the hypothesized mean over the sample standard deviation, that would be this guy, 657, 0.657 over the square root of 24. So let's calculate that. Now again, we could just have the calculator run this test. It'll give me the test statistic and the p-value. I do want to just show you how to do it once, and I want you to practice it once. But after that, we can just, and I will show you how to use the calculator after this. We got to hurry. We only got 4 minutes. Oh, geez. I'm going to pause the video. Type it in. All right, so I typed it in here. Hit enter. Negative 2.41. That is a t-test statistic. Obtain a p-value. All right, so I have a t-distribution with 23 degrees of freedom. My test statistic is negative 2.41, and I have a two-sided alternate. So I need to find the area to the left, and then I need to double it. That is menu, statistics, distributions, t-CDF, from negative that to my last answer, which was negative 2 point whatever, 23 degrees of freedom. So that gives me 0.0122, and you need to double it. 0.024. That is small. Compare your p-value explicitly to the alpha value. This is less than 0.0. What was our alpha? I think it was 0.10. And if we got a small p-value, that means we reject the null. There's our statistical conclusion. Now our non-statistical conclusion. So if we reject, then we do have convincing evidence. Convincing evidence that the, copy this down, true population mean length of subs at this shop of all subs at this shop during the month of interest is, and always put the alternate right here, not equal to 6 inches. So this sub shop is not being truthful with their sub length. Yeah, that's what the test says. Okay. Long procedure, kind of. I'll tell you this. On the last test, guys, this was the one that got people. A lot of people lost a couple, 2-3 points there. You just need to know the whole procedure, right? All right. Now we'll talk about some other stuff.